I'm going to present you here with a few examples working with Bezouts identity and looking at linear combinations of numbers and their greatest common divisor, all based upon the Euclidean algorithm. What I want to do, I'm going to show you the examples. I'm going to give you an opportunity to pause the video, have a go at them, and then come back and check based against the work I'm going to present you. So here you go. It's just going to be two examples for you. Firstly, I want you to find x and y such that 45x plus 63y is equal to the greatest common divisor of 45 and 63. And then the second one, I want you to find r and t such that 636r plus 27t equals 3. So, same type of question. All I've done is change the variables. So pause the video now, have a go at both of them. So first question, find x and y such that 45x plus 63y is the greatest common divisor of 45 and 63. First thing we have to do is confirm the greatest common divisor of 45 and 63. And again, using that, what we'll then be able to do is come up with a linear combination. So we start by looking at our division algorithm, working with Euclidean algorithm as well, and figure out what we get. So it's 63 equals something times 45 plus a number. That's the format we want it in. Well, 63 is the equivalent of 1 times 45 plus a remainder, which is 18. So the remainder is there. It's not a 0. We continue, we go on again. So we look and we want to write 45 in the format of something times 18 plus a remainder. Same idea again. So what we'll do is figure it out. So 2 18s, 36, plus 9 gives me the 45. So I've still got a remainder for this one. I'm still going to do another step. From that point, I then know that 18 is going to be something times 9 plus a remainder. Well, 18 is quite simply 2 9s. So my remainder here is 0. So what that means then is I can confirm my greatest common divisor of 63 and 45 is equal to 9. So because I know it's 9, I know that I'm going to be looking at my original format, and I can rewrite it as 45x plus 63y is equal to 9. So some combination of linear numbers and integers to give me 9, where I've got 45 and my 63. So my next step was to then rewrite these things so that I had it in the format r equals a minus qb. And remember, the one with the remainder is 0, can ignore that. We'll just leave that as it is. I'm going to take the one here where my remainder was 9. I'm going to rewrite it as 9 equals 45 minus 2 times 18. I'm then going to take the first one and I'm going to rewrite it in terms of its remainder and have 18 equals 63 take away 1 times 45. Now, how does this help me? Well, I want to write all of this in terms of 45 and 63 from my original function it's asking me for. I've got an 18 here, but if I take this and substitute it in there for the 18, I can write the entire thing in terms of 63 and 45, and then I'll have the solution that I'm after. So I can rewrite it then as 9 equals 45 take away 2 times the 63 minus 1 times the 45. So I've got it there in terms of that. Now all I'm going to do, expand that bracket, gather all my like terms, and I can start to look at coefficients. What I'm also going to do is swap the sides round so I've got equals 9 rather than 9 equals, just to maintain the format. So if I expand that bracket and start to gather, what I'll end up with is 3 times 45 take away 2 times 63 is equal to 9. And at this stage, if you wanted to check it, you could use your calculator and just fire that in quickly in order to be able to check what we've done is right. So now, if I compare it to the original format, so 45x plus 63y equals 9, what I'm able to do is look at it and tell you straight off what x and y are, just by comparing coefficients. So by comparing them, I can say to you that x is equal to 3 and y is equal to negative 2. So there you go. I found my x and my y such that 45x plus 63y is equal to the greatest common divisor of 45 and 63, which also happens to be 9. So there you go. I've worked it through. using Bezouts' identity, Euclidean algorithm, and my division algorithm to bring it all together. Now the second question was find R and T such that 636R plus 27T is equal to 3. Now this is the same sort of idea. The only thing is I've changed my variables. I'm no longer working in X and Y. I'm working in R and T. Now, just because I've changed that doesn't mean I change the steps. Remember, the variables are there just to represent something. So I can use any generic variable I want. So I've just switched to R and T here to demonstrate that. Now the first step, we have to prove that 3 is the greatest common divisor. And remember, it's the greatest common divisor of 636 and 27. That's what I'm looking for. I want that to be 3. I want that confirmed to be 3. So let's work it through as we normally would. I know I'm wanting 636 equals something times 27 plus a remainder. That's the format we're after. So breaking it down in this manner, what I can say is 636 is equal to 23 times 27 plus a remainder of 15. That'll give me the format I want. Now my remainder's 15, it's not 0, so I go again. This time though, I'm looking for 27 equals something times 15 plus a remainder. Well, in this case, it's 1 times 15 plus my remainder of 12. Again, remainder isn't 0, so we continue on. 15 equals something times 12 plus a remainder. Well, it's 1 times 12 plus a remainder of 3. Again, one more step. Hopefully one more step. Well, 12 is equal to something times 3 plus a remainder. Well, 4 3's give me 12. My remainder is 0. Excellent. Greatest common divisor then is 3. So it's confirmed what I wanted at the start. So now that that's confirmed, what I do is I start working back and I start to rewrite these in the format that we want. So I'm going to take this first one and I'm going to write it as 3 equals 15 take away 1 times 12. I'm then going to rewrite the next line and I'm going to say that 12 is equal to 27 take away 1 times 15. I'm going to take the next line up and I'm going to rewrite that as 15 equals 636 take away 23 times 27. Now remember, we want this whole thing to involve just the 636 and the 27. So I'm going to have to use back substitution to get rid of anything else. Well, first thing I'm going to do is I'm going to take the value for 12 and I'm going to stick it into here. So I can then say fine, so I know then that 15 take away 1 bracket 27 take away 1 times 15 is given by that. What I can do, expand the brackets, gather everything that's the same together, and what I'll end up getting is that 2 times 15 take away 27, well, I know that's going to be equal to my 3. Well, I know I want the 27 kept in. Great. I now have to get rid of the 15. Well, this here, we'll take the 15 and put it in terms of the 636 and the 27 that I'm after. So what I'm now going to do is substitute that in. So I'll end up with 2 times 636 take away 23 times 27 take away 27 equals 3. Now that I've got it, expand the brackets, gather everything that's the same together, and then we'll see what we've got. So expanding the brackets gives me 2 times 636. I've then got take away 46 and then take away another 27. So take away 46 is 46 of the 27s. Take away another one. So it's then going to be take away 47 times 27 equals 3. Now again, if you wanted to, you could go back and use the calculator and double check this is true. But trust me when I tell you, it is. What we'll now do is look at the original expression that we wanted. So the 636R plus 27T equals 3. And just by comparing the two of them, I'm looking at coefficients, I'm able to say from that R is equal to 2 and T is equal to negative 47. So slightly bigger numbers in some cases, but it's still the same set of steps. You remember those sets of steps every single time, and what you'll be able to do is nail one of these questions no problem. Just remember, confirmation, that's the first step. Second step is the rearrangement. Third step, the back substitution. And then the fourth step, compare your coefficients. Follow those 4 steps, you'll nail every single one of these questions that you come up against.